Hello everyone, welcome back to my channel. In today's video, let me introduce to you the concept of logarithms. So, we'll get started. So, this time we are going to discuss the introduction to logarithms. So, what are the objectives? So, we have here at the end of this lesson, you can rewrite exponential equations in logarithmic form. And you can rewrite the logarithmic equations in exponential form, and finally evaluate logarithms. So what is meant by logarithm? So logarithm, this word came from the two words. We have logos and arithmos. Logos, which means ration, and arithmos, which means numbers. So logos arithmos, combining the two words, it means ration of numbers. So this word or this term logarithm was established by John Napier, a Scottish mathematician. So it is the exponent or power to which a base must be raised to yield a given number. Now, by definition, let A, B, and C be positive real numbers such that B must not be equal to 1. The logarithm of A with base B is denoted by log A with base B and is defined as C is equal to log A with base B if and only if A is equal to B raised to the power of C. So we have here the reminders that A must be equal to B raised to the power of C. That's the exponential equation. Then we have to express it in logarithmic equation. We have C is equal to the logarithm of A or log A with base B. So in both the logarithmic and exponential forms, B is the base in the exponential form. C is an exponent, and this implies that the logarithm is actually an exponent. Hence, logarithmic and exponential functions are inverses. So we have here the two types of logarithms. We have common logarithms. Common logarithms are logarithms with base 10. So log x is a short notation for log x base 10. So if you don't see a base under log, so that means the base is 10. So that's under common logarithms. The second is natural logarithms. Natural logarithms are logarithms to the base e. It is approximately 2.71828. So this is actually an irrational number. When we say irrational number again, it is non-terminating and non-repeating. And it is denoted by ln. So in other words, ln x is another way of writing log x with a base of e. So with exponential equation in logarithm form, so write exponential equation in logarithmic form. So if we have 2 raised to the power of 5 is equal to x, we can express that in logarithmic form. Now it will be log x with a base of 2 is equal to 5. Now as you've noticed, the base is 2 here in the exponential equation. The base is 2, so we have there log base of 2, then the x there, you have the 5, the exponent of which is 5 under exponential equation becomes the result of the logarithm or the logarithm. So 2 raised to 5 is equal to x, and the logarithm of x with base 2 is equal to 5. Now let's have more examples. Now write each exponential equation in logarithmic form. Now 5 cubes is equal to 125. So for logarithmic form, that will be log 125 with base 5 is equal to 3. So you have noticed that indeed exponential equation is the opposite of logarithmic equation. Next example, we have 7 raised to the power of negative 2 is equal to 1 over 1 over 49. So in logarithmic form, we will have log 1 over 49 with base 7 is equal to negative 2. Now let's continue writing exponential equation and logarithmic form. We have here 10 squared, or 10 raised to the power of 2 is equal to 100. Now, that becomes log 100 is equal to 2. Since the base is 10, that's under a common logarithm. Okay? So that's under common logarithm wherein the base is 10. So you no need to write base 10. In form, we will have log 1 over 49 with base 7 is equal to negative 2. Now let's continue writing exponential equation and logarithmic form. We have here 10 squared, or 10 raised to the power of 2 is equal to 100. Now, that becomes log 100 is equal to 2. Since the base is 10, that's under a common logarithm. Okay? So that's under common logarithm wherein the base is 10. So you no need to write base 10. Then next we have 2/3 raised to the power of 2 is equal to 4 over 9. So that would be log 4 over 9 with base 2 over 3 is equal to 2. Now let us proceed to more examples. Now write each exponential equation again in logarithmic form. So we have here e squared is equal to x. So again, e is the base of natural logarithm. So we have that specific uh, value for e, which is an irrational number. So if we have e as the base, we will use the ln, or the natural logarithm. So since we have here e squared is equal to x, that will be expressed as ln x is equal to 2. You don't need to write the base e because that's understood. If you will use ln, there is e as the base. Next is negative 2, or the quantity of negative 2 raised to the power of 2 is equal to 4. Now this cannot be written in logarithmic form because the base is negative. There should be no negative base. Now how about writing logarithmic equation and exponential form? So we are now doing the other way around. Now in this case, we have here log 64 with base 2 is equal to 6. So that means our base is 2. So you have 2 raised to the power of 6 is equal to 64. Okay, let's have more examples. If we have log m is equal to n, since there's no base, that's understood that the base is 10. That's under common logarithm. So that's the base is 10, so you have 10 raised to the power of n is equal to n. Next would be log 81 with base 3 is equal to 4. In exponential form, that would be 3 raised to the power of 4 is equal to 81. Next, we have the logarithm of 5 with base square root of 5 is equal to 2. Then for exponential form, we have the quantity of square root of 5 raised to is equal to 5. Next, we have ln 8 is equal to a. So since it's ln, that's natural logarithm, we know it's understood that the base is e. So we have e raised to the power of a is equal to a. Now let us try evaluating the following logarithms. So how we're going to evaluate the logarithms, how we're going to solve it. Now, let's have an example. First example would be log 27 with base 3. Now, to solve this, we will let x is equal to log 27 with base 3. Now, you have to express that in exponential equation. So, log 27 with base 3 is the same as 3 raised to the power of x is equal to 27 in exponential equation. Now we are going to express both sides, the left and the right side of the equation with the same bases. So you have 3 raised to the power of x is equal to express 27 with base 3. That will be 3 cubes. So x is equal to 3. Since we have the same bases now, we're going to equate the exponents. Therefore, log 27 with base 3 is equal to 3. Now let's have another example. Log 625 with base 5. Now let x is equal to log 625 with base 5. Then express it in exponential form. We have 5 raised to the power of x is equal to 625. Now, our target is to make the same base for our left and right side of the equation. Now, we're going to express 625 with base 5. So 5 raised to the power of 4 is 625. Therefore, 5 raised to the power of x is equal to 5 raised to the power of 4. Since we have the same basis now, we are going to equate the exponents. So we have here x is equal to 4. So the answer would be, you have here log 625 with base 5 is equal to 4. So let's continue. So we have here, what about log 5, square root of 5 with base 5? Now let x is equal to log 5 square root of 5 with base 5. Then express this one into exponential form or equation. So that would be 5 raised to the power of x is equal to 5 raised to the power 5 square root of 5. Now our base on the left side is 5. Is equal to, on the right side, we have 5 square root of 5. We have to express this one with base 5. Now you have there 5. Square root of 5 is the same as 5 raised to the power of 1 half. So as you can see, we are multiplying on the right side. 5 times 5 raised to the power of 1 half is equivalent to 5 square root of 5. Now with the same base and we are multiplying, it means we are going to add the exponents. Now, since we have the same bases now, we're going to equate the exponents. You have x is equal to, the exponent of 5 is 1, and the exponent of the other 5 is 1 half. So therefore, we have x is equal to 1 plus 1 half, or x is equal to 3 halves. So the answer would be log 5 square root of 5 with base 5 is equal to 3 halves. Now evaluate this one, the log 0.01. So since there's no base, this is under common logarithm, which we know that the base must be 10. So let x is equal to log 0.01. Then express it in exponential form or equation. We have 10 raised to the power of x is equal to 0.01. 0.01, express that one in exponential form with base 10, which is 10 raised to the power of negative 2. Therefore, 10 raised to the power of x is equal to 10 raised to the power of 2, and negative 2. Then equate the exponents. So we have the same base already. X is equal to negative 2. Therefore, log 0.01 is equal to negative 2. Now it's time for us to have a quiz, or it's quiz time. Find the value of the following logarithmic expressions. Number 1, log 81 with base 3. Number 2, log 13 with base 169. Number 3, log 1/5 with base 5. Number 4, log 4 with base 0.5. Next part is to write the following expressions in logarithmic form. Number 5, 2 raised to the power of 4 is equal to 16. Number 6, square root of 81 is equal to 9. Number 7, 3 raised to the power of negative 2 is equal to 1 over 9. Then next, part 3 is rewrite the following expressions in exponential form. We have number 8, logarithm of 9 or log 9 with base 3 is equal to 2. Number 9, log 4 with base 16 is equal to 1 half. The number 10, ln x is equal to 1. Okay, so just write this on your lecture notebook or activity notebook. So to end this video, let's have a math say. So math may not teach me how to add, love, or subtract hate, but it gives me hope that every problem has a solution. So thank you so much guys for watching, and don't forget to subscribe my channel. Bye!